The Shadow Experiment, a 9th grade conceptual physics video. In the experiment above, a candle gives off light in a dark room. A card is placed between the candle and a screen. A shadow of the card is cast on the screen. We want to find a way to predict how big a shadow will be, based on any other information we have. Eventually, we want to find a math equation. We will draw this setup from the side, an edge-on view. This will help us determine a model. Drawing a representation is a useful skill in physics. We will use it often. So here's the actual setup, and our picture will show the screen, the object, and the candle. Light spreads outwards from the candle. One idea is that it spreads outwards in circles. This is a fine idea. When it hits the object, the part of the circle is blocked, but the rest of the circle continues on. So here we see the area of no light, or shadow. This method of expanding circles is a good method, but a different model for light behavior will lead us to a better equation. In this model, called the ray model, light travels out from the candle in straight lines in all directions. It stops moving when it hits a surface and is absorbed or reflected. Can you see the shadow? The umbra is the same place as it was using the other model. The umbra is another word for the place of no light, or shadow. The ray model is going to be useful to us because it will help us find an equation. The two most important rays are the ones that touch the top and bottom of the object. These two light rays form familiar shapes. Imagine that the rest of the light rays have disappeared. Two triangles appear, one made from the candle and the object, and the other made from the candle and the shadow. These triangles share the same three angles, and they are therefore similar triangles. And because they're similar triangles, we can use them to find an equation. Let's use a letter for the dimensions of each triangle. A is going to be the size of the object, B is the distance from the candle to the object, big A will be the size of the shadow, and big B will be the distance from the candle to the shadow. It turns out that for similar triangles, if you break them in half, the halves are still similar. So using the horizontal length of the triangles, little b and big B, still works for similar triangle ratios. So now the equation can be made from these letters. A is to capital A as B is to capital B, or little a is to little b as big A is to big B. Let's use the equation to find the size of the shadow. 10 is to x as 25 is to 40. We could also write 10 is to 25 as x is to 40. Cross multiply and solve for x. Now try it without the triangles and letters to help you. Setting up the equation is the most important part. Pause the video and try it before moving on. 5 is to 20 as x is to 90, or 5 is to x as 20 is to 90. We get x is 22.5 centimeters.